Okay, so here are just a few examples from excuse me, some section 2.7 that I wanted to cover just to give you in case you missed class or something like that, or if you're studying and need to go back and look over something. So we're doing a proof. We're trying to prove, sorry, this keeps getting caught. We're trying to prove that if segment GD is congruent to BC, BC is congruent to FH, and FH is congruent to AE, we're trying to prove that AE has to be congruent to GD. So, you got your statements, got your reasons. Okay, we'll go through it. Now, the first thing to always do is to mark a drawing. Even before you do the given, just mark the drawing. So we know that GD is congruent to BC. We know that BC is congruent to FH, and since BC has a single mark, FH has to have a single mark. And we know that FH is congruent to AE. Okay, so, and if FH is a single mark, AE has to have a single mark. So hopefully, look at this, they all seem pretty obvious that those guys are they're all four congruent, so that's why those two, AE and GD, have to be congruent. So it's just be a matter of how do we formally state that? Well, first, I'll do the given part. GD is congruent to BC. BC is congruent to FH. And FH is congruent to AE. All that's given. Now, step two, okay? Here's the deal, and it's going to seem like we're doing a bunch of stuff that we shouldn't need to do, but it is actually important. I can see I've gotten through all of them, I marked them, that they're all the same length. However, I've got to try to get somehow to tie GD to AE. The problem is GD doesn't get me to AE. What GD does do is it gets me to BC, because those are congruent, and BC is congruent to FH as well. So, since GD is congruent to BC, and FH is congruent to BC, oh, guess what? By the transitive property, I can say GD is congruent to FH. So that's, step two. Okay, congruent there by the transitive property. Now, I can cancel out this guy here and make the note that, hey, GD is congruent to FH. GD is congruent to FH. Well, now, guess what? Since GD is congruent to FH and AE is congruent to FH, oh, look at that. They're both congruent to the same thing. Now I can cancel that out and say that AE has to be congruent to GD. And if two things are congruent to the same thing, they're congruent to each other by the transitive property. And there we go. Okay. Seems very, seems very obvious in the drawing, but it's how do we explain it in words? That's always the trickier part. Next example. Okay. Next example here. This one is, again, a bit of syntax. It's kind of easy to prove. It uses a theorem we haven't talked about for a bit, but it's easy to see. It's just hard to say. So the first thing we know is x is the midpoint of MN. Now, what that means to us then is the midpoint, if we go back to the midpoint theorem, cuts a segment into two congruent segments. MX is congruent to XN. We also know from the given that MX equals RX. Whoa, that means they have to have the same mark. And hey, what are we trying to do? Well, we're trying to say that RX is equal to XN, which again, like the last one, seems pretty obvious, all the same measures. So what we're going to have to do then is find a way to say that. So again, 1 is all the given stuff. X is the midpoint of MN, and MX equals RX. Now step 2, okay, this is the part where, again, this is like this almost memorized that we can do this. If you're given the midpoint, okay, if you're given the midpoint, you're going to have to use the midpoint. And what that means is we're going to use the midpoint theorem. And the midpoint theorem states that if you're the midpoint, you create two congruent segments. So I can say MX is congruent to XN by the midpoint theorem. Or you could just write out midpoint makes two segments, makes, the two parts congruent or something like that. But it's easier to say midpoint theorem. It's a lot less work. And if you forgot what that is, that's from section 2.5. The midpoint theorem is. Okay. Now here's the other part that's like kind of a matter of, technically it's called syntax, but it's just like how we say this. I want to say xn is equal to rx, and I know that mx is equal to rx. So notice this is in terms of congruent. The third step, which is the most annoying step in this problem, is I have to say mx equals xn by definition of congruent. I have to translate it from congruence to equality. And the reason is, if I go back now, I know that mx is equal to rx, and that mx is equal to xn. So if two things are equal to the same thing, they have to be equal to each other, which is what we're trying to prove. Xn equals Rx. So we're done. And that's the transitive property. If two things are equal to the same thing, they're equal to each other. Okay. All right then, last problem we're going to solve. This is the toughest one. This is the one that takes the most work. I know in this one that RS equals XY. So RS equals XY, which hopefully looks like it. I also know that ST, and I don't know that it is equal to WX. And I put 2 marks on it because I'm saying these two are equal. I want to say 2 separate segments are equal that are different. So these 2 marks denote that these two are the same and that these two are the same with a single mark. Now our goal, and it's easy for me to do this with a highlighter, so sometimes it helps to have a highlighter, is to prove that RT, this whole segment, is congruent to WY, this whole segment. Now informally, this is very, very easy to argue. If I said, okay, RS is 6, well that means XY is 6. So 6 and 6. Now you don't do a proof this way, but I'm just giving you kind of a background. RS is 6, XY is 6. Great. And then I also said, hey, ST was 2, that means WX is 2. 2 and 2. Okay. Well, how could I say that RT is the same thing as WY? Well, I just say, oh, it's 6 plus 2, and 2 plus 6, they're both 8. They have to be the same. And okay, that seems pretty obvious. Well, that's what we're going to do in the proof. Okay. Now it's harder than it seems because again, there's like this, how do we bring these things in? How do we say this? It's very, very mathy. But what we'll do first is we will say, again, statements and reasons. And to be honest, I think this is one of the hardest proofs we have to do all year. And it's not that it's hard to make sense of, it's hard to say. That's the difficult part. So, first given, and I'm going to write this in a specific way on purpose. I'm going to write RS equals XY, and underneath it I'm going to write ST equals WX. Excuse me, given. Okay, now, here's the second step, and this is one of 2 steps that nobody ever sees to do, but it's the reason I picked these numbers up here. We know that RT has to equal WY with numbers because I said 6 plus 2 equaled 2 plus 6. Well, that's what I'm going to do next. I'm going to say RS plus ST equals WX plus XY eventually. That's what I'm going to get to. So what I need to do is add those parts. Now I can do that because RS and XY are equal and ST and WX are equal. So I'm adding the same thing to both sides. So step 2 is saying that the length of RS plus ST has to equal the length of XY plus WX. And what that is that's just the addition property. Not segment addition postulate, just addition property. I just added something to both sides. Now, there are 2 steps left. This is the complicated step that no one ever really thinks they have to do. But my third step is going to be this. I haven't said anything about RT or WY yet. I need to bring them into the problem. Well, what I know is that RT is the two parts of it added up. I know that RT has to equal RS plus ST. I know that WY has to equal WX plus XY, and the reason I know that is that's the segment addition postulate. If S is between these 2 points, this part plus this part has to add to the whole. And again, this is what also makes this one difficult, is we don't use segment addition postulate. People just don't think to use that way. They don't realize that, oh, I can build up the full segment by adding the 2 parts together. And then last but not least, step 4, hey, if RS plus ST equals RT, and XY plus WX, I know I reordered it, but it doesn't matter. Okay. Let me do this with highlighter, it might stand out better. So RS and ST equals XY. That does not stand out at all. Let's do it. Just do a colored marker. Let's do a green one. RS plus ST equals RT, and XY plus WX equals WY. I'm going to replace RS plus ST with this guy. I'm going to replace WY plus XY, WX plus XY with WY, and now I'm going to say RT equals WY. Now somebody might say, well, isn't this transitive because these two guys here, RS and S, they equal RT? No, it's not. I'm actually physically replacing this expression, cutting this out and plugging them in here and doing this as well. When you're replacing something, it's substitution. And it's a very subtle difference. And a lot of people get tripped up with it, but it's not transitive. Transitive states, hey, I know 2 separate things. RS plus ST equaled like 7, and RS plus ST equaled RT, so RT is 7. That's not what I'm saying. I'm just saying, hey, replace this guy with RT. Okay. So here are examples doing these 3 problems. Hopefully that helps out and makes a little more sense. If not, come in. We can look through problems and talk all you want. Okay, thanks.